Hey everyone, Mr. Newman here, and today we're going to learn about factoring trinomials using product, sum, and a few other tricks at the end. So this is quite a long video, so bear with me. I'm also going to start off this video a little bit differently. First, I'm going to go through the process and just write it down real quick and have you guys look for observations. And then we're going to talk about how to do this, the steps, and then we'll do a handful of practice problems, including some special examples. And so you may want to bookmark this video and come back to it for reference later. So let's go ahead and get started. First off, here is how you factor. I'm going to write down, this is step 0 because I'm just going to write down the original expression. Then I'm going to write 2x squared plus 6x plus 5x plus 15. That's step 1. Here is step 2. Here is step 3 and the answer. So that is that trinomial factored. It's 2x plus 5 times x plus 3. And I want you to jot down a few things you noticed, observations. All right, now that you got some things, here's what I noticed. I noticed that this is just the opposite of multiplying. Notice, multiplying I put over here on the left, going down is multiplying. This thing I wrote down, all those steps, is just the exact opposite of that, and we call that factoring. So factoring and multiplying are opposites of each other. That's helpful to know because if you're good at multiplying, or you can practice that, if you can just work backwards, that's factoring. Now, it's not as easy as it sounds, but the more you multiply, the better you'll get at factoring and vice versa. Another thing I noticed was that this 11x got split into 6x and 5x. Did you guys see that step? The original equation, or sorry, the original expression has 11x, and we broke it into 6x and 5x. And I'm going to talk with you guys about how we do that. But first, I want you to notice that we always split up from the original step. Step 1 is splitting up that middle term, the b term. We call it the linear term because there's an x on it. Then I also noticed that these two here are our greatest common factors. So we found the GCF twice in step 2. We found the GCF of the first 2 terms, and then we found the GCF of the second 2 terms, and that's the opposite of distributing. If we distributed the 2x here, if we said, all right, 2x times x, we get 2x squared. 2x times 3, we'd get 6x. So I want you to notice that. Likewise with 5x, and 5 times 3 is 15. So that step, to get to step 2, that's the opposite of distributing. Last thing I want to show you guys is that this last step is weird, and it is also the opposite of distribution, or distributing. So going from step 2 to step 3. However, if you're comfortable with multiplying, that will not be too much trouble for you. All right, let's go through these steps one at a time, and you can use this as a reference. So first thing you need to know is how do we figure out how to split up b, the coefficient of the x term. And when I say b, you need to look up here and notice, all right, we have ax squared plus bx plus c. That's called standard form of a quadratic equation. A is the x squared term, b is the x term, and c is the term that doesn't have any variables. We call that the linear term. The answer to that question is something called product sum. The product, we call that the product in part because we multiply a and c to get it. The sum is always just the b value. So in this first example, the product is going to be 2 times 15, or 30. The sum is going to be 11. So the question we ask is, what 2 numbers have a product of 30 and a sum of 11? In other words, what 2 numbers multiply to get you 30 and add to get you 11? Now, if you're having trouble figuring that off the top of your head, that's okay. What I would recommend doing is starting to write down the factors. So if you list those factors, that's what I'm doing when I list these numbers under the P. Those are all the numbers that multiply to get you 30. And you can just start in your calculator and type in 1 times 30 is obviously 30. Then divide by 30 by 2 and see if that gives you a whole number or an integer. If it does, you're in business. So 2 and 15. Divide 30 by 3, you get 3 and 10. Divided by 4, you don't get a whole number, but divided by 5, you get another whole number. And once the second number catches up to the first number, then you know you found all of them. Here, I look and I see, which of these add up to 11? 5 and 6 add up to 11. So those two numbers, 5 and 6, are going to be the numbers that I break 11x into, 5x and 6x. Now, notice I didn't put the x's there, but that's because we're just filling in the blanks here. You always need to write the x's on those two. For the next step, we're going to find the GCF of the first two terms and the second, and the third. In the last two terms. So let's look at this: 2x squared plus 5x. The GCF of these is x. Go ahead and write down. Find the GCF of each part, and I underline the two parts in green. So the GCF of the first two is just x. Oops. Sorry, I had a little typo there. So the GCF of the first two terms is x, and so when we factor out the x, we're left with 2x plus 5. Likewise, in the second half, the second two terms, when you take out a 3, you're left with, 2x plus 5 as well. And one important thing here is to notice that these two must be the same. They must both be 2x, or if 2x plus 5 is in the left parentheses, 2x plus 5 must be in the right parentheses. So they must be the same. Now that we have those two things in the parentheses the same, the last step is just to write out each binomial. And just as a reminder, to make this easier on you, that is the opposite of distributing. That's the first step of multiplication, is the last step of factoring. So what does that look like? Well, you have two sets of parentheses, and you write down the thing that shows up twice, 2x plus 5, 2x plus 5. That's in one of the sets of parentheses. The other is the thing that's between. So do you see the x plus 3, kind of what is left over? X plus 3 there, that goes in the other set of parentheses. So let's do a few examples together, and I'll let you guys try some on your own. The first example, we're going to write down P and S for product sum. If you want to write out the words product sum, that's great. The product is 6 times negative 5, in other words, negative 30. And the sum is going to be negative 13. So what multiplies to get negative 30 and adds to get negative 13? Let's start listing factors. No. Oh, wait. Aha. So one tip is you don't need to list all the factors out as long as you're keeping your sum in mind. I know I need to add to negative 13, so there we go. 6x squared plus 2x minus 15x minus 5. Notice I split the negative 13x into positive 2x and negative 15x. Now, we look for our GCFs of the first two and the last two. GCF of the first two is 2x, and what's left behind is 3x plus 1. That is, when you divide out a 2x, you're left behind with 3x plus 1. On the right side, I'm going to write this in red, so don't copy this down yet. If I take out a 5, I get negative 3x minus 1. Well, look, these are not the same. So that can't be the correct answer. So let's erase it, and let's try to factor out a negative 5. Aha! Now that I've factored out a negative 5, the thing in the parentheses, the two binomials, are the same, so we can continue. The last step, for some reason it didn't include step 3 here, but you have it on your paper. The last step is to write down the two parts. We get 2x minus 5 is one factor, and 3x plus 1 is the other factor. For this one on the right, let's practice this example together. Write down product sum. The product is 1. Remember, there's an invisible 1 in front of the x squared. 1 times negative 5. We get negative 5. The sum is going to be negative 4. Let's list out the factors of negative 5. Well, negative 1 and 5, and 1 and negative 5 are all the factors. That's nice. 1 and negative 5 add up to negative 4. So that's what we're going to split negative 4 into 1x and negative 5x. Now find the GCF of the first two, and x is all that comes out, so we're left with x times x plus 1. On the right two, I see they're both negative, so I'm going to take out negative 5, and I'm left with x plus 1. The last step is to write down both binomials. X plus 1 shows up twice, so I'm going to write that down. And x minus 5 is what's in between, so that will be the other binomial. Flip on over. We're on the back here. I'm going to do a few more examples with you, and then we'll move on to some special cases. So product sum, product is 12, sum is 13. I list out all the factors of 12. I see that 1 and 12 add up to 13. So let's split 13x into 1x and 12x. Now let's find the GCF of the first two. I get x is what I can take out. So when I take out an x, I'm left with 3x plus 1. On the second two, I can take out a 4, and I'm left with 3x plus 1. So the last step is 3x plus 1 times x plus 4. For the next problem, product sum, the product is going to be 60, 6 times 10. And so one tip here, if you have trouble figuring out all the factors, start with 1 again. 60 divided by 1 is 60. Then go to 2. 2 times 30 is 60. Go to 3. 3 times 20 is 60. 4. 4 times 15. And 5. 5 times 12. Oh, wait. I'm going to stop right here. 6 times 10, but I don't need to write that down because 4 and 15 multiply to get me 60 and add to get me 19. So that's how I'm going to split up my 19x. There we go. We split up 19x into 4x and 15x. Now, let's GCF the first two. Found a 2x. And find the greatest common factor of the last two. We got a 5. Writing down the binomials, 3x plus 2 shows up twice. And so the thing that's left over is 2x plus 5. All right, what if b is negative but c is positive? This isn't really a special case. It just takes a little bit of extra thinking. So the first thing is when you write the product sum, 2 times 12 is 24, and the sum is negative 11. So we have to think, okay, what multiplies to get me net 24 and what adds to negative 11? Well, if you write down the factors of 24, notice none of these add up to any negative numbers. This is where you have to be clever and think, aha, but a negative times a negative will get you a positive and add up to a negative number. So let's try our negatives. Negative 1 times negative 24 gets me positive 24. Now that doesn't add to negative 11, so let's keep going. And I keep going and I find out, aha, negative 3 and negative 8 multiply to positive 24 but add up to negative 11. From here on out, it's mostly the same. There's an exception, so I'm going to find the GCF. Notice it's very easy to make this mistake though. If I look at negative 8x and 12, I go 4 is the GCF. I'm writing this in red right here because I don't want you to write it down, by the way. If I take out a 4, notice that the things in the parentheses are not the same again, so that cannot be the correct factor. So let's step back. Instead of positive 4, let's try to factor out a negative 4, and I get the same thing in the parentheses, so we're good. Now, 2x minus 3 will be one factor, and x minus 4 will be the other one. Let's try this one on the right here. So product sum, product of 15, sum of negative 8. Two numbers have to add up to a negative but multiply to a positive. They must both be negative then. And if you skip writing the positive factors in this situation, that's perfectly fine because they've got to be both negative. Negative 3 and negative 5 add up to negative 8 and multiply to 15, so we're going to use those. Split up negative 8 to negative 3x and negative 5x. Find the GCF of the first two. And the GCF of the last two, you want to choose negative 5. That way, they're both x minus 3 is what's left over in both cases. That's going to be the first thing I write down, the first factor, and x minus 5 is the second factor. Moving on, one other tip, one last thing I want to teach you is to always check for the GCF first, because this can make your life way, way easier. In this first case, I see that 2 goes into all three of those terms. I'm going to pull a 2 out, and when you divide each of those by 2, you're left with x squared plus 3x minus 4. Now I'm going to use product sum on just the inside trinomial, the smaller numbers. And yes, you could do it on the larger numbers on the outside, but that would be trickier. That'd just be bigger numbers, would take more time, and you'd have to remember to do the GCF at the end anyways, so you might as well do it now. So 1 times negative 4 is negative 4. Our sum is going to be 3. Not a whole lot of factors. Negative 1 and 4 add up to 3, so we're good to keep going. Notice how I'm putting the 2 on the outside with parentheses. That's very, very helpful. Let's do the GCF of x squared and 1x, and we get x times x minus 1. GCF of 4x minus 4 is 4, and we're left with x minus 1. So the last step, leaving the 2 on the outside, is to write down the 2 other factors. So 2 is a factor, x minus 1 is a factor, and x plus 4 is a factor. On the right here, this is a good case if you want to try this without finding the GCF and see how painful it is. Knock yourself out. I see that a 4 goes into all 3 of those terms, so I'm going to pull a 4 out. Product sum will be 6, and the sum will be 5. So 2 and 3. That's much faster than if you had to do product is 4 times 24, which is over, let's see, it's 96. That would be much more difficult than a product of 6. Now, split 5x into 2x and 3x. Find the GCF of each of those parts and write down the factors. Here are a few practice problems. I want you to try these on your own. Okay, let me do this for you now that you tried it. 3 times x squared minus 6x plus 9. Product sum, negative 3 and negative 3. Multiply to 9 and add to negative 6. So I'm going to split negative 6 into negative 3x and negative 3x. When you GCF, there you go. And last step, you write down the 2 factors. On the right here, notice that we only have 2 terms. And that's because the first term, the x squared term, is here, and the last term, the constant, is here, but we're missing the middle term. When you're missing the x term, that means b must be equal to 0. So when you're doing product sum, well, first of all, there are no GCF, so I'm going to rewrite it exactly as it is. When you're doing product sum, the product is 1 times negative 25, which is negative 25, and the sum is going to be 0 because there's no x term. This turns out to be a very simple case. It's called difference of squares, and we'll talk about it more later on how to do that quickly if you haven't already learned. And you'll notice you have the same number, just positive and negative. Those add up to 0. So we do want to write down negative 5x and positive 5x in the middle. Then we take out the GCF, and we get x minus 5 times x plus 5. Thank you very much for watching.